In this first lesson 6.5 video, we're going to be using the triangle inequality theorem to find possible side lengths of a triangle. So earlier we did an exploration on this theorem, but let's just remind ourselves of what it is. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle has to be greater than the length of this third side. So for us, what we're really going to be focusing on is if we want to know if lengths can make a triangle, the shorter two sides must add up to be more than the longest side. If that's not true, then the three lengths cannot make a triangle. So in this picture here, we would want to be able to check, does the length of AB, which is one of the shorter sides, add with the length of BC, the other shorter side, to be more than the longest side? That's what we need to ask ourselves. So we're going to go ahead and apply this to a few problems. I need you to turn to page 188. I know it says 187 here, but it's page 188 in your student journal. And we're going to go ahead and do number 9, 10, 11, and 12. And then we're going to talk about number 13. In number 9, it says, is it possible to construct a triangle with the given side lengths? So in all four of these problems, we want to know if the shorter two sides add to be more than the longest side. That's what we need to check. We're going to be checking that statement there. So in number 9, the two shorter sides are 3 and 12. When I add 3 plus 12, I get 15. Is 15 greater than 17? It is not. So this is no. Those could not be the lengths of a triangle. Number 10, 5 and 16 are the two shorter sides. When I add them together, I get 21. Is 21 greater than the longest side, 21? It is not. They're equal. It's not greater than. So this is no. And number 11, the two shorter sides are 5 and 7. When I add the two shorter sides, I get 12. And is 12 more than or greater than the longest side, 8? It is. So the three lengths in number 11 could form a triangle. Number 12, the two shorter sides are 10 and 3. If I add those together, I get 13. Is 13 greater than the longest side, 11? It is. So those three lengths could form a triangle. All right, and number 13, it says a triangle has two sides with lengths 5 inches and 13 inches. Describe the possible lengths of the third side of the triangle. So in this problem, we know two of the sides, and we don't know the third length. And our job is to just describe what could the length of that third side be. Now, when we do this, we have to consider two possibilities. The first possibility, perhaps the third side is one of the shorter sides. So here's one situation. I'm going to kind of divide it up. Where in my triangle, I'm going to call it X, the side I don't know. X and 5 are the two shorter sides, which would make 13 the longest side. So I'm just going to put a little note that X would be a shorter side, one of the shorter sides. If in this situation, if this were the case, we would know that my two shorter sides, X and 5, we know that they have to add up to be more than the longest side. So this inequality has to be true. X plus 5 would have to be greater than 13 if the third side is one of the shorter two sides. I'm going to go ahead and solve this inequality. To get x by itself, I'm going to subtract 5 from both sides. And this tells me if x is one of the shorter two sides, x must be greater than 8. If it's not greater than 8, it could not form a triangle. Now, the other possibility is maybe x is the longest side. So that would make 5 and 13 the two shorter sides, and x is the longest side. If this is the case, then we would know in order to be a triangle, the two shorter sides, 5 and 13, would have to add together to be greater than x, which is the longest side. When I add 5 and 13, I get 18. So what this means is 18 has to be greater than x. Or if I flip this around, x must be less than 18. If x was 18 or larger, these two shorter sides would not add up to be longer than x. So I have this range here. X has to be greater than 8, but it has to be less than 18. So when we go and we take these two situations, we're going to put them together as a compound inequality. So what I do there is I'm going to take this statement, x is greater than 8, and I put x in the middle. Okay, so I have x is greater than 8, but it is also less than 18. So x can be any number from 9 to 17 if we're talking about whole numbers. So as long as x is greater than 8 and less than 18, then those lengths would form a triangle. So this is our final answer. We get our final answer by taking our two possible scenarios for x and putting it together.